So this time, we are going to try to implement our logic circuit using this application, Tinkercad, and try also to simulate the circuit using the 74 series IC. In the previous video, it was explained how the teacher will create a class, and this time I will also explain how the student joined the class, and it is presumed that the class code and also the nickname of the student has already been distributed. So this time student will join the class and implement the design or create his own design. Okay, if you're a student and would like to join the class, make sure that you remember the class code and also your nickname. So it's either you click sign in or click the join your class button. Okay, so presume that we have a class. We join the class 7 and X8 CN 9W AF2L. So click go to my class. Sorry, there's something wrong in the code. That is AF2L. Okay, so let's try one student nickname here. Click join with nickname and then I'll type the nickname. This is just a trial. So you input your nickname and then click that submit. So this is the class Digilog 21, which was created by the teacher. Okay, so here is the environment of student Tinapay. Okay, his nickname is Tinapay. So you have here the menu, drop down menu. You have the new design notification and then you log out. Then you also have here the options where student Tinapay would choose what particular activities he or she is going to make. But since he is joining the class circuits, let's try to click circuit first, and then here there is your classes. So Tinapay joins Digilog 21, which is created by the teacher BG8311. Okay, so since this is circuit, this is not 3D design subject, so we have to click circuit. Okay, so this is the design that was created before. So if Tinapay would like to create another design, so just click, or another circuit design, so the student has just only click the create new circuit button. Okay, we're now at the simulation area. So let's try to implement the expression a is equal to x prime y plus xy. Okay, so in the previous video it was explained there how to connect how to create a logic circuit using the 74 series IC. Okay, so the universal ICs are 7404, 7408, and 7432. So what are those ICs? 7404 is the inverter or a not gate or inverter. 7432 is the OR gate, and the 7408 is the AND gate. So again, we are going to we're going to implement the expression x prime y plus xy. Okay, so let's start. Before that, we are going to change this one. Tinkercad will give you a default name or nickname, so you can rename that like love 2. Okay, then you press the enter key. Okay, so when you implement, of course, you need a breadboard. Okay, breadboard. So you click, you just search here breadboard. So there is a small and bigger breadboard. Let's try this component. You just drag the component here. Okay, we have here, by the way, so this is a bigger one. There's also a smaller one, this one here, but that's up to you if you spend a lot of components. So I mean, if you need to spend a lot of components, then you need to have a wider breadboard. So might as well use this one. So we'll delete a smaller one. So just like what I have told you, this connection here are connected horizontally, and this one, this two, and this portion here are connected horizontally. I mean vertically. So this is horizontal connection, and the other one is vertical connection. Same with here. Okay, let's have a new one. So we need to have, aside from the breadboard, we need to have 7404 IC. Sorry, 74 here in the component, 7404 IC. So we have here, remember this is an inverter, so you just drag the component here for a while. And then we need also 7408. This is an AND gate. So as stated in the label, it is an AND gate. And then another one is 7432. This is an OR gate. And then we also need a switch, DIP switch. Okay, just type in here DIP. So for what purpose? This will be used for our inputs. In the given expression, we have two inputs, which are X and Y. So we have this DIP switch. Since there are only two inputs, we'd rather use this blue one, not this red one, the bigger one. Okay, and also the next one is a LED, this one. So this is our indicator whether our output is correct or not. So we have to track it. So we have the breadboard, the three ICs for the inverter, 08 for the AND, and 32 for the OR gates. So let's mount the component. We will start with the IC. Okay, we'll mount the IC here, somewhere here, and then so this is for the inverter. The next is the AND. Again, this what we are implementing is a sum of product. So And the next IC to be used after the inverter is the AND gate, and then the next one is the OR gate. Okay, so to recall, these three ICs have the same pin number for the voltage, right? And the same pin number for the ground. So as you can see, if you are to point the mouse pointer in each leg, that indicates whether it's a power or it's an input, output, or it's a ground. So 7404 has only one input but 6 gates, I guess, 6 inverter inside. So the next here is the output, something like that. And then here for the 7408, 2 inputs. This is a 2 input gate IC. So input, then output, then another one, input, output. Then here it's input, output, then input, output. Yeah. And then the other one is ground. Same thing, same layout with the 7432, but this 7432 is an OR gate. So it's for adding the two expressions. No? Okay, so prior to connection or wiring, something like that, we have to connect first. The technique there is to connect first the common power or positive pins. So here, so since that is about power supply, the wire that is the color of the wire is going to be used is red. So here, just click the hole and then drag it to the next power connection or power pin for the next IC. Then this one also, since this will be connected to the next IC, so just click the lower dot to establish connection and then drag it to the power pin of the other IC. So we already have a common connection with the three ICs. Another one is the ground also. We will do the same thing. Just drag, you connect the ground of the IC to another IC, and then to the next IC also. Okay, so we already have a common ground, and take note that we have to also to follow the color coding, especially for the supply. No, positive is red and ground or negative is black. So we have to change the color of this into black. The other one also. Okay, we now come to the battery supply. So we forgot to choose another component, which is battery. Like I would like to emphasize that the battery, the voltage for the IC is not more than 5 volts. So it has to be like a minimum of 3 volts, not 9 volts, but 3 to 5 volts. Okay, so we will choose battery, and I'm going to use this 3 volt battery like that. Okay, since we cannot rotate this object, we'll just drag this one like this one. This is the positive polarity. So if you wanted this one to be the positive polarity or to be the positive supply, then we can just simply use the upper portion. And for us to remember that this is positive, we have to follow the color code. And another one, the black one, this one here. So we already have supply for the horizontal connection. just like that. Okay, now, so this is a common power pin. So for us to have a space to connect to the upper power, since we are going to put, or I mean, establish a common connection, so we'll just drag this one. We'll transfer. Oh my god, wait for a while. Okay, for a while, just remove this one here. Right. So here we're going to put a connection going to the top, the positive supply. And then here we're going to put a common connection to the ground. Then you can establish a connection somewhere here and then to the ground. Okay, so we have to change the color of the wire because this is a negative supply or ground. Okay, so this time we're able to establish common ground and common positive supply. Now let's try to mount the DIP switch. We'll just simply let's try to drag it here. So we will connect it to the positive side. Oh, okay. I just noticed that this lower is the positive here, so we have to change it. Okay, so we have here the negative, and then this one, the lower one, is the positive, so we also have to drag this one. Okay, my fault, there's a symbol. Although you can do that one, you can interchange for as long as you observe the proper polarity. That's it. In this case, we just follow the symbol here. Okay, let's presume that pin 1 is the X and pin 2 of the switch is the Y. Okay, so we're going to get a connection from the switch to the IC. So again, take note, our expression is X prime Y plus XY. So we will get X first. So we'll get here input X. So we'll try another color. Say we wanted to have pink. Okay, so we have X here. Since X is X prime, so therefore we have to put that one in the first input of the inverter, so that we can have a prime output. Okay, this X prime, and then we are going to add this output X prime will become the input of the first input of the AND gate. Okay, so that's it. So the pair for X prime is the Y. So we'll get a connection from the from the Y. You can also choose another color to represent the Y input. Okay, wait. So we'll try to drag here. somewhere here, drag it, and then put it in the second input of the AND gate. So this is input, input, and then this is the output. Okay, this is the output, which is x prime y. So the x prime y will be placed to the first input of the OR gate. Okay, so we have it here. So the next term is xy. So we'll get another input from x here. You may tap in this connection here, and you aside from that, you can also tap connection from here because the input here is x, right? So you can tap here in this area, this one here. Okay, so we'll try to create or connect a wire somewhere here because we're tapping the X. And then since we are going to okay, you cannot view the other wire, no? Okay, wait for a while. I would suggest that we will use this portion here so that you can see clearly the connection. Okay, so we will input here the X, get a connection from here for the X, and then go to input. This is input, right? Input pin, so we have to click it here, and then we'll change the color because it's the X, and then another Y is for the another is for the Y. Okay, so we have it here, Y. So I intentionally did this not to overlap the wire so that you can see clearly the connection. So this is for the Y. And then the output will go to the new, so the output of this is XY, so we are going to connect this one to the second input of the OR gate because we are going to sum up the two terms, the X prime Y plus XY. Okay, so we already have the final output here. So this is the final output. We'll just drag a wire here. So let's say we wanted to use another color for the final output. Let's say orange. Okay, so to test whether our circuit is working properly, then we have to do this. Drag this one. You can use the, what do you call this one? The LED. Like the output will be connected to the negative leg of the LED, and then this one again, I would like to remind you that the left leg of this LED, which is the cathode, it means negative, and then the right leg of the LED is the anode, which is the positive. So since this is positive, we have to connect this one directly to the positive positive supply. Like, you can do that here or you can do it here. Okay, so that's it. Now let's try to simulate our circuit. Just click this start simulation. Okay, the output is 1. So the LED lights up. So what about if the signal or the value of x is 0, 0, the value of x is 0 and the value of y is 0. So we'll just have to push this one. This is somewhat like a very tiny toggle switch. So since 0, 0, you push it up. So the output is 0 because the LED here is turned off. But actually, the output of this circuit is based on the constructed truth table. But since we have not discussed yet about how we construct the truth table, then I'll just presume that 0, 0 is 0. I mean, if the value of x and y are both zeros, the output is 0. And if the value of if the value of x is 0 and the x is 1, the output is 1. So that has already been computed. So let us try to check whether our circuit is correct or implementation is correct. So 0 and 1, it lights up, so meaning the output is 1. What about 1, 0? So x is 1 and the y is 0. The LED is off, so meaning to say the output is 0. And what about 1, 1? X is 1 and the y also is 1. The output is 1, or meaning the LED lights up. Okay, so based on our simulation, the truth table, and also based on the truth table that I constructed, if x is 0 and y is 0, the output is 0. If x is 0 and y is 1, the output is 1. And if x is 1 and y is 0, the output is 0. And if both x and y are 1, so therefore the result is 1. So this is our circuit, and we did a very good simulation, and we also come up with a correct output of the circuit. Once if you wanted to, by the way, if you wanted to stop simulation process, you just click this green button, stop simulation. Okay, now you can export this one by clicking export, but the extension name, file extension is .brd, so that can only be read by a special program like this. No? Okay, so if you wanted to have to capture an image, it's either you just simply press the print screen, or you can run the snipping tool. Just type snipping tool in the window and then click. So this is my snipping tool. I just click it here and then click new. So we can now capture the image of our circuit. So we have it here, and then save your work. Now, if your teacher would want you to submit the image of your implementation, then you can just use the snipping tool, save your work, or you just copy and paste it to your folder, or to be safe, just use or just click the save snip. Okay, so that's all for this video, and I hope you learn from this. And by the way, the design that you just made is automatically saved, and it is already part of your design. So this is, since I use the account of Tinapay, then this work will be saved to the student Tinapay. Okay, to check, you just click the arrow left for you to return the main menu, and as you can see, we're able to, Tinkercad was able to save the work lab 2 here in circuit option. So this is part of the this one here is part of the circuit project. It's not the 3D design, but the circuit project specifically on the class Digilog 2.1.